Nothing better than talking about what's inside your cup of coffee, right? So I'm going to do a sort of interactive presentation. I want to do a little survey here, and I'm going to randomly ask one of you, okay, some questions. And I hope you're very sincere with me. All right, so when you go shopping, let's say, when you go shopping for groceries, what are the things you look at to decide what kind of coffee you're going to buy? You a coffee drinker? Okay, good. So you're in a supermarket, a bunch of brands and stuff. So what you look to decide what coffee you want to buy?
I look at the brand. I'm particular about the brand.
You look at the brand?
What we usually take at the house.
You normally what?
What is the specific brand that we all in the house would take?
Okay, all right. Anybody else want to answer that question? What kind of, what you look at? I have options. You look at the price to decide? No, okay. You look at the brand? Yes, all right. You look at the coffee bean origin? Okay. Oh, I have a very exquisite audience here. And what about other things you look at? A nice package? What? Producer. Okay, the producer. You use it's very popular now in Brazil too, this machine. Yeah, an espresso from Nestle, right? Yeah. Okay, so there are things that we look at when we're in a market shopping for groceries, and in the case of coffee, that's the kind of thing you can look at to compare. And actually, to be honest, when I first came to the United States, I didn't know what to pick because, you know, price-wise, they kind of range, same range. Of course, they are higher, but never less than, let's say, $5 a package, right? But anyway, so now I'm going to ask another person. Now let's assume that you are temporarily in another country, that you're not familiar with the brands. So looking for the brand is not going to help you because you're not going to find your brand. So what would be the factors that you would consider to decide which one you're going to buy? Spontaneous question. Price. Okay. What would be another thing? Local producer. Okay, sounds good. Mm-hmm. All right. What? Oh, you ask somebody. Yeah, that could be a good idea too. Yeah. All right, so now we're going to compare those answers. So let's move to another alley of the market. And now you are deciding what canned soup you're going to buy, okay? And then what kind of information you look in the packaging to help you decide which one you're going to buy. Okay, so let's see. What kind of, you're going to buy a can of soup? You are in a market that you don't know nothing about brands. What are you looking in the package? Okay, what did you say? What kind of soup? Okay, so, all right. So you're not interested in the price, brand. You just want to see how the soup is made, something like that. Okay, all right. So normally here in the United States, that's what people would do. They look at the calories per serving, right? They look at the sodium content. They look at the fat content, maybe. Price, of course. And other things, right? Has to be what? Okay. The taste. Yeah, you cannot tell about the taste. You just have that information. All right. So what is the main difference when you're looking to buy a coffee and you're looking to buy a can of soup? Now, what are the informations you can get from both products? So all the products that you buy have a label. They have what we call a nutrition facts. And that is even true for a potato, actually. A potato, if you get a bag of potato, they'll tell you what is the average fat, what is the average carbohydrate, everything in that potato. And again, guess what? Well, maybe you didn't notice that the potato does have a label. But coffee is the single food product that you buy regularly that you know nothing about nutrition facts. And even though you keep buying it, right? I mean, we went to the moon, to Mars, wherever. We're going to put a station over there and study. And we still don't know what is inside the coffee that you buy. Isn't that amazing? I think that strikes me a lot. How come nobody thought about that? Okay, so what's inside your cup of coffee? All right, so today you will learn the main composition of the coffee that you drink every day, that should be in a nutrition facts label, how to select a good and healthy coffee, and what are the main benefits of drinking coffee regularly. Okay, first we need to know, in order for you to decide what coffee you want to buy, you should look at the coffee beans composition. And why I'm saying composition? Because even though the gourmet ones, they say 100% Arabica, right? Those are very expensive. Arabica is more expensive than Robusta. Actually, there are two species that normally mixed when you buy your regular package of coffee, grounded coffee. There will be a mix of Arabica and Robusta, okay? So why they mix? Because it's only Arabica is too expensive. And also because the flavor that each brand has, they are based on the mix of the beans. Because, of course, being 100% Arabica will have some sort of a particular flavor that sometimes is not the taste of your clientele. So your clientele wants a little bit more with more body, with more acidity, with more something like that. So that's why they mix. But fundamentally it's because of the price of the beans. Let's be honest. And okay, so second thing, and why the reason of coffee beans composition, because we're going to show in the next slide, there is a difference. Being two different species, they do have a different composition of the main constituents in coffee. And then, of course, that will be, we're going to focus on caffeine and chlorogenic acids as their main constituents. But coffee is much more than that. We're going to see that in a minute. So according with the coffee species, the chemical composition varies, and we have two, which is coffee Arabica and coffee Robusta. Within coffee Robusta and within coffee Arabica, there are the good selected beans, and there are the not so good selected beans. And then there is a variation of what they call coffee mistakes, that will be the best, or defects, that will be the best translation, that in terms of, for instance, to export, that has to have a maximum of those defects in each bag of coffee that they buy. So, of course, the coffee that, for instance, Brazil exports is one of the best coffee they produce because they want to send the one that has less defects. But internally, sometimes you might find cheaper brands that have a bitter taste sometimes because have more defected coffee beans. But being an importer of coffee, you guys most likely getting the best coffee of every part of the world because, we want to keep selling to you guys because you are the #1 consumers. Okay. So, second thing we're going to be interested in to know on the composition of the beans is how those beans were roasted. And I can tell you right now, there's not much room to variation in terms of roasting. It's a high temperature that is kept. What changes is a little bit the temperature that you kept and the time that you keep roasting. So the longer you roast, and of course the higher the temperature, the darker will be the coffee, right? Because you're burning longer, right? So for that, it was created actually like I said, according with the length, time, and temperature. Also, that will determine a change in the composition of those compounds. And I'm going to show you why in a minute. So, but you're going to ask me, how come, without having just a package on my hand, can I know with the coffee process of roasting, right? Well, there's one thing that they put nowadays in the package, which is the words light, medium, dark, and very dark. So this is a translation of the degree of roasting of the beans, okay? And this is actually corresponds to a number in the Specialty Coffee American Association, SCAA, that goes from 25 to 95, and it exactly corresponds to how dark is your coffee or how long it was roasted. So, and the third thing, of course, is going to be the brewing process. We're going to go back each item separately. The brewing process here in the United States most likely will be what we call the dripping process, that you put the powder in your filter and then you turn on your machine and that brews the coffee in a boil hot water that pours into it, right? And but we're now starting to have, and that opens up a huge area for me to research, which are those machines that comes with their special, the Keurig thing. Everybody's buying that thing because they don't want to worry about buying the package of coffee, pouring the coffee, so they're just finding the coffee they like and they're using those machines. I myself, I tried to adapt to it. I couldn't, because I couldn't find anyone that has enough powder inside that gives the flavor that I'm looking for. So I still prefer to put the amount of powder that I like. But I can see in offices and, physicians, consultation, waiting room, that is perfect, right? Just have the machine over there. And so that's another thing that I keep thinking. What would be the influence of brewing coffee in a plastic container? Because that is a plastic container. So what is the interaction of the plastic with the coffee at high temperatures? I don't know. So it's a question to be answered. But anyway, so coffee brewing process. So normally it's dripping that we use, right? Then we have this new thing. Of course, you have the espresso thing, which is a pressure, water, boiling pressure through the grounds coffee, and that brews that coffee very strong quickly. And also we have the Arabic way to brew coffee, which is percolation, is different way. We also have that Italian machine that you put the coffee in the middle, the water in the bottom, and the water boils. And what goes through the powder gets to the top of the machine, and that's you. So The difference mainly between those methods that I'm saying here right now, the dripping one that we use, that you put a filter on it, you are retaining in the filter, for instance, the fat that you have in a coffee. It's not much, but there is some. If you drink a coffee, a Arabic coffee, for instance, that doesn't have any filter, you're going to see the oil in the surface of the cup of coffee. You can see that oil. Well, that oil also have healthy properties. Don't worry, if you're drinking coffee with oil, it's not that you're going to be drowning in oil. It's just getting just a little bit, which is good. All right, but anyway, the brewing process also interferes in the final amount of the chemical composition. So we have at least 3 incognitus: coffee composition, beans, origin, how it was roasted, and how it was brewed, right? So all 3 different things that can influence the final coffee that you drink. Okay, so what this all means for you guys? Well, let's break down in simple words. Chemical composition, for instance. You see here, we have, oops, all right, come back. No, all right. Caffeine, that for years and years, they were blaming coffee because of caffeine. They still blame a lot. And sometimes also good stuff in coffee was because of caffeine. Everything was caffeine. And if you look at, caffeine is actually 1%, sometimes even less than 1% in the coffee that you drink every day. Probably I would say is in between 0.5 and 1.5. It's less than 1% of the coffee that you drink. But then look at the chlorogenic acids, between 5 and 9%. So you have much more of the good stuff that we are studying right now, which is the chlorogenic acid, than the caffeine. And nobody was talking about that. How come? They was just not seeing, blind, right? So now the research is more into looking at those compounds. Of course, there are many. There are the ones that are in higher concentration. And I myself, for instance, I stick with those that are in higher concentration, which is the 3, the 4, and the 5 caffeoyl quinic acids. 3, 4, and 5. They are, yes, isomers. They just change the position where the caffeoyl is bound to the quinic acid. Just a change. But that change we know from our pharmaceutical science studies that changes in the position of a radical in a molecule could mean completely active, could mean no active at all. I can tell you at least 2 drugs from the top of my head that is a mix of isomers, and one of them is active and the other isn't. For instance, warfarin. Warfarin is a mix of 2 isomers. One is active, the other is not active. So same thing could be here, right? And because of stability of chemistry-wise, if you remember from the previous slide that I showed you, the caffeoyl quinic acid, the 5 caffeoyl quinic is more stable because the radical is in between 2 hydroxyls, so it's more stable. So when you move to 3 and 4, you kind of lean towards some sort of a conformation or configuration that is not that stable. Actually, they are kind of actually transforming between each other. So when you measure 3, 4, and 5, you're going to find 5 in higher concentration, 4 and 3 in equivalent concentration, because they tend to transform into 5. But doesn't matter. They all together, we consider them as a one thing, and we measure as total chlorogenic acids content in the coffee. And that will be, that percent, oh my God, I keep doing this. And that will be the total concentration of those chlorogenic acids. Look at that, we also have sugar. Yeah, coffee comes with sugar, not enough to make it sweet, but does come with sugar, lipids, amino acids. This is the good stuff here. Have you had any idea that you do have a niacin in your coffee? Vitamin P, niacin. You know, niacin that gives birth to nicotinamide, right? Which is so important in a phosphorylation and oxidative process in the energy build up in our body, right? And we have, and look at that, it's a good concentration, 0.5%. It's not, so coffee actually should be in the future, from my understanding, just like Americans does with the foods that enrich with things. I would enrich coffee with niacin to get the normal necessary amounts of niacin per day. Since you drink that every day, why not get all the niacin you need in your coffee? You don't need multivitamins. You can get from coffee. Trigonelline is a precursor also of important molecules. So, and in these others here, there are also, I didn't call attention, minerals. Look at that. Potassium, iron, calcium. I'm not talking about sodium. Sodium is very low on coffee. It's high in potassium. So it's all good stuff. You cannot blame coffee in the composition of being bad. Even took care of low sodium and high in potassium. Okay, so let's move. So this explains why you're looking at composition, because if you're having only Arabica, you're going to have less of some things, more than others, and things like that. The roasting effect on chemical composition depends on the roasting process, and that's what I'm showing here, where you see that when you roast, the only substance that sticks in is caffeine. Everything else goes away. You had 3, 4 of minerals, 5, 7 of chlorogenic. This all is going to degrade and disappear from your coffee. So, a coffee that is dark, probably just have caffeine. I'm sorry. If you like it, that's okay, but you're not getting this good stuff here. So I will try to move to a lighter color of coffee. Okay. Okay, that's what the tree looks like of coffee. So you just learned that a coffee is normally a mix of 2 species, that depending on the mix you have a different chemical composition, and that depending on the roast process you will have or not the good stuff inside the coffee. All right, so how can I know that looking to the package? Because it's still not telling you how. All right, so truly you can't because there's no information on the package. But there are ways to kind of infer that you're getting a better coffee. How are you going to do that? You're going to do by selecting, look for information about the bean's origin, if your coffee comes with. Look at the color of the ground coffee. So like I said, if it's a dark coffee, it's going to have a SCAA number that tells you that it's really dark, and that's not what you're looking. You're looking to intermediate color. The good coffee, when you look at the ground coffee, is a chocolate color. It's not dark maroon. It's a chocolate color, actually. Okay, and here to help you with the colors, I have this, which is that scale that I told you that SCAA made in order to give you information about the concentration, the roasting process. So you see they go from 25, 30 to all the way to 90, and the number goes in opposite direction with the color. So the higher the number, the lighter is the color. So a very dark, that we call the Italian coffee, that they do the espresso. I used to say that espresso is a shot of caffeine. That's what I think. And that's why many people can't stand it. Because, you're looking for something else. You just don't want just that, that boom, right, of caffeine. You want something lighter, flavorish, aromaful, right? Okay. So then you have the dark, moderately dark, medium, moderate light. So I would say something in between here, 65 and 45. That's the range you are looking at to get a good coffee. Why? Because of this that shows in the side panel. Dr. Lima, that person that I show you, that was my mentor, together with the people from the Embrapa, Brazil, that studies the composition of components on the coffee beans, they come up with a concentration of those different classes of chemicals in different kinds of coffee, roasted in different conditions. And they found out that, like you see here, the CGA that I called as chlorogenic acids, which are the ones that are in high concentration of green coffee, and then as you burn, as you roast, those CGAs turns into lactones that are in red. So as you start burning, those lactones start to appear to the point where you have as much as CGAs, lactones, the good stuff, and as you see, they are here between 65 and 45. That's where you have what we call a balanced coffee. And you can see also that caffeine is yellow here, doesn't change the whole time, is the same. Meaning that doesn't matter for how long you keep the coffee roasting, caffeine is thick because it's the only component of coffee that is thermostable. So doesn't break down. And then we come up with this proposition, mixing the scale of, mixing the scale of the color of the coffee with mixing this scale with this one, and then we come up with 3 groups of coffee. And that will be, now showing here? Okay, I'll tell you. The first group will be where the CGAs are dominant, and it's exactly this first one here. The CGA composition predominates. Then comes the one that we think is the good one because balance out all the components, and will be from 45 to 65. And then the ones that doesn't have much thing left, that we don't say you should take, which are the ones that are in 75 or 35 and 25. So sometimes in the package you do get that information too, of the scale of SCAA. So now you know. All right. So I think I gave you some tools for you to be able to better select your coffee in any country that you go. Right? Doesn't need to know a brand, you need to look at the price. You just have to bear in your mind that you want to know the composition. And like I said, the mix of the beans varies. And why varies? Even varies within the brand. And that's the thing. Because, why? Because nowadays the industry is not interested that you're getting a lot of chlorogenic acids. No, they don't care for that. What they care is that they want to keep the aroma and the flavor that you are used to. So if they can get that for a lesser price, meaning mixing a poorer bean in between and still get the flavor and aroma, and that's where come the cuppists. That's what they do. I don't know if you ever heard about. It's a profession in the coffee industry. The person tastes the green coffee, they smash that with water and they taste it, and from that they can tell if that went according with the roasting process of the company will give the taste and aroma they are used to. So because of that, you can even tell, well, I'm sticking with the brand, I'm sticking with the same composition. No, you're not, because there's no compromise of the industry. They are not putting in the label what is the composition they are giving to you. And they are not interested in giving because they're going to have to stick with that. And, you know, coffee market is the second after oil. Do you know that? It's the second. It's petroleum is the first one. Then comes coffee. In terms of money, running. So, of course, so I'm kind of with a flag alone in this battle because, you know, the big interests, they are really not interested in, you know, in selling health. They want to just sell aroma and flavor. Doesn't matter if it comes with healthy compounds or not. So it's our duty as consumers to request, to be more, you know, selective, you know, and start looking for things that are, you know, start not buying those dark ones, you know, start doing, you know, your job. Look for what is good for you. And that maybe, who knows, maybe, will change you know, along the time and with all the papers that are coming out about those compounds. I still think that the first company that sells their coffee based on the composition facts will be the next Starbucks. Just have to trust that I'm saying is true. And come with me and put money on my research, right? Because what I intend to do is continue the research I did with the genotyping. My idea is to get those healthy volunteers, get them in a facility, do all the points that Dr. Jeff Lieb mentioned about PK, look at the PK of those compounds, do a real study of PK, PG, and come up with an ideal composition of a coffee. You know, at least the closest ideal. You know, like I said, the one does that one first, oh my God, there will be tons of paper to back him up, and, you know, we're going to charge whatever he wants for that. You don't need to eat the feces of the animal who drank coffee and then, right, and pay tons of money. Just drink coffee. You don't need to go that far. All right. So do I have questions about the coffee composition?
Yeah. Any questions? So maybe I'll ask Dr. Kish.
Let me make just a last survey here. How many of you look at the color of the ground coffee before you prepare it? Okay. And did you notice what I said about, you know, the dark and the not that dark? Okay. No, you didn't. Okay, I told you. So you're biased. Okay. All right. Okay.
So maybe I'll ask you to dedicate her.
Yes.
For the second presentation. Yeah.